Okay, we're going to talk about work and power. The work is the amount of energy that is consumed in an action, like moving an object. That's why when you work, you get tired because you're wasting energy. The power is the rate of work that is being done every second that passes. So basically, how fast you are doing your work. The faster you are, the greater the power that you are using. Same thing with the cars. That's why usually people say, "Oh, this car has a specific amount of horsepower." Or, no, this one has more horsepower. That means that it consumes more energy. It does more work on every second, and that makes the car faster. Okay. The formulas for work and power are work equals force times distance, and power equals work divided by time. And the units for work are joules, which is going to be a capital J, and the units for power are watts, which is a capital W, or also horsepower, which is an HP, but we don't use that one that much. We use more the standard unit of watts. So let's try applying the concept in here, okay? Find the work done by the force and the power that was used to finish in time. So we have a guy pushing a box with a force of 40 newtons, and he wants to travel this box to travel a distance of 170,400 centimeters. And that thing has to be done in a time of 1.2 minutes. Okay, so let's try first finding the information of the data of the exercise, okay? I know that the force is 40 newtons. Yeah. I also know that the distance that has to be traveled is, if you know this is in centimeters, we need to convert it to meters. So it's 170.4 meters. You need to divide by 100 to convert from centimeters to meters. And the time that we have to do such task is 1.2 minutes. Now, because it's in minutes, we need to convert it to seconds, because we do not use minutes, we use seconds. So 1.2 minutes, to convert it to seconds, you need to multiply it by 60. 1.2 times 60 is going to give you 72. Okay, 72 seconds. Now that we have all of this information, we need to see what are we looking for. We're looking for the work that's been that is being done with that force, and the power that is being used. Okay, so let's find work first, because we cannot find power because we need work. So work equals force times distance, right? So the work is going to be equal to, the force is 40 newtons times the distance, which is 170.4 meters. That will give me a work of 6,816 joules. Remember, it's a capital J. Okay, so I already found the work. Now I'm going to find the power. So power equals work divided by time. Yeah. So power equals, the work is 6,816 divided by the time, which is 72. And if I divide those two numbers, that's going to give me an answer of power equals 94.6667 watts. Okay, and there we go. That's how we find work, and that's how we find power. Now, what happens if the force that is being applied is in a diagonal? That means even though the force in this case is 42 newtons, is not been properly used. Okay, what do I mean? This is the case when you waste your energy, you do a lot of stuffs, unnecessary stuffs, you get really tired, and you didn't do any work. Okay, like it was something useless. So that's the idea. You're applying the force, but not in the direction that you should apply the force. So you're wasting a lot of energy unnecessarily. The only energy that's gonna count, that's the energy for the work. So we need to be careful of that thing. Okay, so let's see. What will be the force that is being applied in this work? The force will be 42 cosine of the angle, which is 30 degrees. Yeah. Remember that if I use cosine, what I'm getting is the horizontal force, right? So from this diagonal, I got the horizontal force, which is 42 cosine 30, is less than 42. That means we're not using the entire 42 for doing the work. We're using part of the 42 for other stuffs that are unnecessary. The distance is 2.47 meters, and the time is 0.6 minutes. So 0.6 times 60 will be 36 seconds. Yep. Okay, this cosine 30 newtons. So what are we looking for? We're looking for the work, and we're looking for the power. So let's put the formulas. Work equals force times distance, right? So work equals, the force is 42 cosine of 30 degrees, yeah, times the distance, which is 2.47 meters. That will give me a work of 89.8415 if I round it, joules. Remember, work, the unit of work is joules. Okay. Now that we have work, we can find the power. Power equals work divided by time. That means power equals 89.8415 divided by 36 seconds, right? So the power, if I divide those things, will give me a power of 2.4956 watts, right? Yeah. Now that we found work and we found power, that's it. Okay, so remember, the idea is, if I'm not pushing in the direction where I'm trying to move the object, I am wasting energy unnecessarily. Okay, so always try to, when you're moving something, to push in the direction you're trying to move. If you're pushing this way, is not the best option. Okay. Same case if you push in a diagonal, okay, like in this case, it will be the same idea. The force is not 45. Yes, it's 45, but you're not using the 45. You're using less, okay, because the angle is taking some force from you. Okay, 45 cosine of 60. Okay, newtons. Now the distance in this case is 0.6 kilometers. That means it's 600 meters. If you convert it, you're gonna notice that it is actually 600 meters. And the time you have for moving that is a time of 30 seconds. So you have to do a lot of work in a really tiny fraction of time. That means the power is gonna be a lot. Yeah, it's gonna be like a really huge power, because you have to do stuff fast. You have to work fast. The work's not gonna change. Doesn't matter if you take more time or less time. You still have to move that object the distance with a specific force. So the work's not gonna change. But the power, yes, the power depends on how much time you want to do, or you want to take for doing the action or the activity. So let's see. Work equals force times distance. Work equals 45 cosine of 60 times the distance, which is 600 meters. If I multiply that, that will give me a work of 13,500 joules. That's the amount of energy that you need to consume in order to move that box from this place to the other place. Okay. Now, what about the power? It has to be a lot of work that you consume every second, because otherwise you're not going to be able to finish on time. You have to work a lot. Okay, so 13,500 divided by 30 seconds. Okay, if I do that, that will give me an answer of 450 watts. You can see that's a lot of power. You have to consume 450 joules every second so that you can finish in time this work. Okay? And that's it. That's how we work, at least on a basic level, the ideas of power and work.